This video is about extending my breadboard demonstration of a Tayloe detector to act as a simple software-defined radio receiver. I said I probably would not make this video because Dr. Volt already did something similar, but I changed my mind because I have something I want to show you. See below for links to Dr. Volt's video and my previous video, but now take a look at this. This program is called WSJTX. It implements special communications protocols that can work with weak signals. One of these is called FT8. Amateur radio operators use FT8 to make contacts around the world, exchanging a small amount of data, including locations. WSJTX is processing the I and Q data from our simple radio and is receiving these signals. The trivial breadboard circuit is receiving fairly weak signals on the 40-meter band from quite far away. For example, we can double-click on this one, and it actually tells us that it's coming from 1,371 miles away. So now WSJTX has been running for a couple hours in this run, and it's received and decoded quite a few messages, and we can click on some and get distances. That's 451. That one's 6,239. That's quite remarkable. So there's a lot of messages here. And so there's another program that runs alongside WSJTX, and it looks at the messages and analyzes them. So let's take a look at that program next. This is Grid Tracker. So it's analyzed the messages that WSJTX received and decoded, and it shows the locations of the stations that we're hearing on a map. And it also shows these dashed lines when two stations are interacting with each other. So you can see that we've received some messages from quite a long way. So the receiver, the simple radio, is in central Texas. And so here's somebody in the Japan area. That doesn't look right. Looks like the Aleutians. Maybe that's a Japanese island over there. And then also in Europe, we have messages all the way from Ukraine, and as well as Madeira, what's that? Bulgaria, France, and then lots of them in the U.S. and down here Martinique in the Caribbean. So I think it's quite incredible that the simple radio can receive messages from so far away, and I wanted to show that to you. But I must admit that this is more of a testament to the quality of WSJTX, perhaps, than it is to the radio. WSJTX is just remarkable in its ability to process weak signals. Here's the radio built on the breadboard. You can see it's a simple and even crude thing. The yellow wire goes to the antenna. The wire on the left goes to the audio jack of the PC. It's easier to see on a schematic. The SN74LV4052 analog multiplexer and the 3.3 nanofarad capacitors implement the Tayloe mixer as described in my previous video. Its job is to shift a region of radio spectrum down to the audio frequency range. The resulting I and Q signals are amplified by the op-amps set up as differential amplifiers. Again, see my previous video. The I and Q signals are then fed into the two channels of my PC's sound card. The sound card converts the analog signals to digital form. Software on the PC filters, demodulates, and otherwise processes the signals, and the result is a radio receiver. WSJTX is an example of this kind of software. Quisk is another example. I'll show it later. One difference from my previous video is that I'm using a Raspberry Pi Pico to generate the VFO or F1 signals to inputs B and A. These are square waves at the center of the frequency range we want to receive. One is 90 degrees out of phase with the other. The Pico is better than the AD ALM2000 at supporting a more continuous range of frequencies up to maybe 15 to 20 megahertz. I can set this VFO frequency by sending a command to the Pico via a serial port. The antenna is a roughly 20-meter wire slung over a tree in my backyard. It connects to capacitor C7. It's important to have a decent length of wire as the antenna, and it helps that it's outside. The two 10K resistors bias the incoming signal to 1Com. The next software we will use is Quisk. It's more complicated than something like GQRX, but it works well with IQ signals from sound cards. Its main display shows the region of RF spectrum that the Tayloe mixer has translated to the audio range. You see radio stations as peaks in this display. The gray box shows the area of the spectrum that is currently tuned. The software filters out everything outside the gray box and then demodulates whatever is in the box using the currently selected demodulator, in this case AM. The frequency of the square waves the Pico produces sets the center point of the display. Radio designers call this the local oscillator or VFO frequency. The display is showing the upper part of the AM medium wave band in the United States. The LO frequency is about 1589 kilohertz. Values up to about 15 or 20 megahertz work in the simple radio. Let's give it a try. Here are some local AM radio stations.
Or go there at your convenience, download podcasts of previous shows. You can also download the free app SoundCloud. Strikes me in such a positive way when a couple can hang on. Because again,
This station is so powerful it gets better if I put a resistor in the antenna circuit to attenuate it.
For 72 months. Let me find you the perfect 2024 GMC Sierra.
Now I'll remove the resistor.
For all your AC needs, Bryant, whatever it takes. Texas AC license D67670.
Today's hottest.
So that was some local AM radio stations. That powerful one has an antenna not far from my house. My PC's sound card samples at 96K, so we can see 96 kilohertz worth of bandwidth at one time. This lets us switch between two signals without having to enter the frequency to tune.
Y que pidió la Virgen pues construir la casita sagrada. El Papa del 2022.
So this last station is at 1560 kilohertz, and the other one was at 1600. This signal is actually a sign that my little receiver isn't very good. The F1 frequency going into the Tayloe mixer is right here. So this signal is really just a phase confusion of this signal. So you can see that it won't sound very good. So in a better receiver, this wouldn't be here at all. It's just a sign that the phase information is noisy, and so this isn't entirely suppressed by the Tayloe detector. Here's an amateur radio operator on 40 meters single sideband.
Well, I'm going to send you the same report. You're a 5x9 straight up S9 on my meter here in North San Diego County. Thanks for joining us.
Now, let's try a higher frequency. WWV time signal on 20 megahertz. I think that's enough demonstration. Mainly, I wanted to show that such a simple receiver can receive amazingly distant FT8 signals using WSJTX. That really surprised me. I don't want to leave you with the impression that this simple receiver is a good receiver. It isn't, but it does very well given its extreme simplicity. Better receivers would include additional analog filters as NA5Y shows on his channel. I'll put a link below. I'll end here. I hope you enjoyed this video, and thanks for watching.